Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and I'm here with Victor. Before we dive in, I'd like to remind our listeners to rate our podcast on whatever platform you're tuning in from. Your feedback means the world to us.
Absolutely, Sheila. And hello, everyone. We're excited to continue our journey through Season 2, where we're exploring core hole-punch technologies. Today, we're in Chapter 2, focusing on Hyperswarm networking, and specifically, we'll be discussing topic-based networking.
That's right, Victor. And to kick things off, I've got a quiz question for our listeners. Here it is. In Hyperswarm's topic-based networking, what common cryptographic function is used to transform topics into a format suitable for the distributed hash table? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really gets to the heart of how topic-based networking operates under the hood. I'm sure our listeners will be intrigued to learn about the cryptographic magic that makes this system work. Shall we start by explaining what topic-based networking actually is?
Absolutely. Victor, could you give us a basic explanation of what topics are in the context of Hyperswarm?
Certainly. In Hyperswarm, topics are essentially identifiers that peers use to find and connect with each other. You can think of them as meeting points or rendezvous locations in the vast ocean of the Internet. When a peer wants to join a specific network or share specific data, it uses a topic as a way to signal its interest and find other peers with the same interest.
That's interesting. So if I understand correctly, it's like each topic is a unique channel that peers can tune into. Is that a fair analogy?
That's a great analogy, Sheila. It's very much like radio frequencies. Just as you tune your radio to a specific frequency to listen to a particular station, peers in Hyperswarm tune into specific topics to connect with other peers interested in the same thing.
That makes sense. So how exactly are these topics used in Hyperswarm? What's the process of a peer joining or leaving a topic?
Great question. In Hyperswarm, when a peer wants to join a topic, it does two things. First, it announces itself under that topic, which is like saying, "Hey, I'm here and interested in this topic." Then it also looks up the topic to find other peers who have made similar announcements. This process of announcing and looking up is how peers find each other using topics.
I see. But Victor, wouldn't this mean that anyone could see what topics a peer is interested in? That doesn't sound very private.
You're absolutely right to bring up privacy, Sheila. This is where some clever cryptographic techniques come into play. Hyperswarm doesn't actually use the raw topics directly. Instead, it uses a cryptographic hash function to transform the topic into a fixed-size string of bytes. This hashed version of the topic is what's actually used in the network.
Oh, that's fascinating. So it's like the topics are encoded before they're used. But why use a hash function? What advantages does that provide?
Great question. Using a hash function provides several benefits. First, it ensures that all topic identifiers have the same length, which is helpful for efficient storage and lookup in the distributed hash table, DHT. Second, it provides a level of privacy, as you can't easily reverse the hash to find out what the original topic was. And third, it distributes the topics evenly across the DHT, which helps with load balancing.
That makes a lot of sense. So, to use our radio analogy, it's like encrypting the names of the radio stations so people can still tune in if they know the station, but they can't easily figure out what all the available stations are just by scanning the frequencies.
Exactly. That's a perfect extension of the analogy. Now let's talk about some real-world implementations. Many decentralized applications use topic-based networking for discovery. For example, decentralized chat applications might use topics for discovering chat rooms, or decentralized file sharing systems might use topics to find peers sharing specific files.
That's really cool. Are there any common misunderstandings or pitfalls that developers should be aware of when working with topic-based networking in Hyperswarm?
Absolutely, Sheila. One common misunderstanding is thinking that topics provide security or access control. While the hashing provides some privacy, topics shouldn't be used as a security mechanism. If you need to restrict access to a network, you should implement additional authentication and encryption.
That's an important point, Victor. It sounds like topics are more for discovery and organization rather than security. Are there any best practices or tips you'd recommend for developers using topic-based networking?
Definitely. One key tip is to choose your topics carefully. You want them to be specific enough to connect the right peers, but not so specific that the network becomes fragmented. Also, consider using a combination of public and private topics. Public topics can be used for general discovery, while private topics, perhaps derived from shared secrets, can be used for more secure communication.
Those are great tips, Victor. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. The question was, in Hyperswarm's topic-based networking, what common cryptographic function is used to transform topics into a format suitable for the distributed hash table?
Ah yes, the big reveal. The answer is that Hyperswarm uses a hash function, specifically the SHA-256 hash function, to transform topics. This creates a 32-byte identifier that's used in the DHT.
Thank you, Victor. To summarize what we've learned today, topic-based networking in Hyperswarm is a powerful mechanism for peer discovery and connection. Topics act like meeting points for peers, but they're hashed for privacy and efficient distribution. While topics are great for organization and discovery, they shouldn't be relied upon for security. And remember, choosing your topics wisely is key to effective network design.
Excellent summary, Sheila. I hope our listeners found this deep dive into topic-based networking informative and engaging.
Indeed. And to our wonderful listeners, if you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement keeps us going. Until next time, happy coding.